I thought I would go over ANOVA real briefly here. ANOVA is also analysis of variance. ANOVA, again, it's a method of comparing means and variances for several different variables. The assumptions of ANOVA, which there are things we need to have in place in order to run ANOVA, are that we have a random sample, we do have some normality about the data, and there are tests you can run to understand that. And then you want to make sure you have the same sample size for each variable. You don't have a sample size of 100 for variable A and 450 for variable B. And you can use different software packages to run ANOVA. Some things that we look at when we see those statistical packages and the outputs, if we look at the F statistic and the P statistic. The F stat measures the significance of the ANOVA test. And typically, anything over the value of 0.3, we can basically assume there's a difference existing in the data that we have. So what we say is if it's over 0.3, there is a significant difference in the data sets. With the P statistic, we're measuring the significance level of the difference of means. So this measures the null hypothesis and the statistical significance of that. So basically, we're setting a bar at 0.05, 0.01, or 0.001 as the P statistic. After you run the ANOVA and you get your F and P statistics, you might find that the difference is statistically significant. So you know there's a difference in the data sets, but this doesn't necessarily mean that it's big, important, or helpful. So you need to look at the effect size. So this will let you know that the difference between the two data sets is statistically significant. There's some tongue twisters in here. And the effect size will allow you to understand if it's important or meaningful. If your effect size is closer to 1.0, that means the difference is more meaningful. The effect size is higher. Another thing we can look at is a Chi-square test. So this is a non-parametric test of the relationship between two variables. So we're looking at small sample sizes here. It has less assumptions than the parametric test ANOVA. So it's the non-parametric brother or sister to the ANOVA. And it's not as sensitive to the differences in the data set. And overall it can be useful for small samples. Again, it's just looking at the difference in the relationship between two variables. There are a whole host of different software packages that you can use to run different statistical analysis. For stuff in the academic field, a lot of people use SPSS, SAS, and R. In the professional world, you're likely not going to run ANOVA specifically or Chi-square specifically, but you can look at differences among data sets through Excel and other programs. Overall, it's important to understand what ANOVA is, even if you're not specifically using it on a day in and day out basis. So ANOVA and Chi-square, again, we're looking at differences of data sets. How does the results from variable A significantly different from the results from variable B and so forth? So that concludes our short discussion about ANOVA and Chi-square for this presentation. However, if you're interested in learning more, or if you're going to be more involved with academic research, I would definitely look into taking a specific course that includes ANOVA or Chi-square for non-parametric studies.